Hi everybody! On today's show we solve linear equations where letters replace numbers. There's going to be letters, letters, letters everywhere. So we're going to be solving equations like we have the past 2 days, except they're going to look a little different. So to get us started, solve these three equations in this opening exercise here. So solve each of these equations for x. I'm going to give you a second to do that. So hopefully you paused the video and did some solving. Let's see how you did. So here's x. It's being multiplied by 2, and then I subtract 6. So let's add 6 to both sides using the addition property of equality. And I get 2x equals 16. Well, 2 times x is 16, so I'm going to divide and get x equals 8. Not bad. So I have negative 3x minus 3 equals negative 12. So this has the same structure as that one, so let me add 3 to both sides. Those add to 0, and I end up with negative 3x equals negative 9. Well, I don't care about negative 3 times x. I'm going to divide by negative 3, and I get x equals positive 3. This is different because I have a times x minus b equals c. Well, how do I get this x alone? Well, this equation has the same structure. It has the same structure as these two equations here, where first I added this value that didn't have an x. A times x equal, I have no idea what c plus b is, so I'm just going to leave it as c plus b, because I don't know what c and b are. Well, how do I undo a times x? A number times x, I'm going to divide by a. And I end up with x equals c plus b over a. And that's my solution. That's the value of x that makes that equation true there. So our answers are going to look a little different. It's not going to be the nice x equals 3. It might end up being x equals c plus b over a, and this is actually a nice one. Some of our answers might get a little ugly. So solve the following two linear equations. Look at their structure to see how the first equation can help us think about the second. So let's look at them. X plus 5 over 2 minus 7. X plus a over b minus c. So it has the same structure in that it's x plus something divided by something minus c. So let's solve this first one here. And it's going to look a little weird how I solve it, but you'll see what I'm doing. I'm not going to combine like terms. So I think of my order of operations. I add 5, divide by 2, subtract 7. So let me add 7 to both sides. X plus 5 over 2. Notice how I'm going to write it. I'm just going to leave it as 3 plus 7. And I'm going to, over here, it's really 10. I'm going to do it two different ways. Well, how do I undo that division? I'm going to multiply by 2. Well, if I multiply this side by 2, I need to multiply this entire side by 2 as well. So I get x plus 5 equals 2 times 3 plus 7. If I do that over here, that's just really 20. Well, how do I get x alone? I'm going to subtract 5 from both sides. And I end up with x equals 2 times 3 plus 7 minus 5. Or 2 times 3 plus 7 minus 5 is also known as the number 15. 10 times 2 minus 5 gives you 15. How does this relate to this equation here with these variables? Well, it has the same structure, so we're going to use the same exact steps. I added 7, so I'm going to add c to both sides. X plus a over b. Well, I have no idea what d plus c is, so I'm just going to leave it as d plus c. Then we undid this division by multiplying by b. But I can't just put a b there. I need to multiply that entire side by b. X plus a equals b. You can distribute it, but you don't need to. You don't need to distribute it there. You can, but it's up to you. And then finally, I need to get rid of that a by subtracting it. So I get x equals b times d plus c minus a. And that's my solution. Notice it looks just like this solution over here where I didn't combine like terms. When I actually did the arithmetic of 3 plus 7, 10 times 2, I noticed that it's still b times d plus c minus a. It's the exact same structure as that equation there, except I'm not combining like terms. I'm just leaving it in terms of these letters here. Solve this equation for x. So solve the equation for x. That means my answer is going to be x equals. I want to solve the equation for x. So x, I want to get x all by itself in terms of a, b, c, and d. So that means get x alone, and that means a, b, c, and d are in the answer. In terms of means that's just in the answer. So I know a lot of you are going to want to distribute, so I'll start by doing it that way because I know you love the distributive property. Remember, who are we solving for here? I want to get that x by itself. Does this a plus b have anything to do with x? No. Sorry, ab. Does this negative c? No. 0, 0. Ax equals d minus ab plus c. Well, that's a times x. How do I undo a times x? I'm going to divide by a, because I want to get x all by itself. So I end up with an answer of x times d minus ab plus c all over a. And there's my value for x. It looks horrific, and it is awful, but that's my solution. What if you didn't distribute? What if you didn't distribute here because notice there's just one x, so you can just use inverse operations to get us where we want to go. Using inverse operations, I'm adding b, timesing by a, and then subtracting c, so let's work backwards here. Let's add c to both sides. I get a times x plus b equals d plus c. Undo multiplying by dividing by a. I get x plus b equals d plus c all over a. How do I undo adding b? I'm going to subtract b from both sides. Except that subtracting b has nothing to do with this fraction here. D plus c all over a minus b. That answer is equivalent to that one. I can't just slash out those a's there. But I can divide everybody by a, and it ends up looking like this answer here. So these two answers are equivalent. Those two answers there are actually equivalent. More than one way to solve it. You get the same answer in the end. They just look a little different. Consider the two linear equations. Look how they're different than the other ones. There's x's on both sides again. Solve for x. Get x all by itself. So let's see what we do here. Maybe we add that 5x to this side, where I get 8x plus 4 equals 6. I'm going to subtract 4 from both sides. 8x equals 2. Divide by 8. X equals 1/4. So how does that help me solve this equation over here? Well, the first thing I did was I added 5x. So let me add cx to both sides. And I end up with, oh, wait a second, 3x. I can't really combine like terms here. So let me just write it out. Ax plus cx, that's that 8x there. That together gave me 8x plus b equals d. Well, then I subtracted that 4. So let me subtract the, well, not 4. Let me subtract the b from both sides. Ax plus cx equals d minus b. But this is different because over here, I only had 8x. But here I have this ax plus cx. So when we combine, when I say combine like terms, we're really undoing the distributive property. Watch this. What do both of these have in common here? They both have an x. So let's undistribute that x out, and let's see what we're left with. What times x is ax? A. What times x is cx? C. Check my work here. Watch what I did. I undistributed it. What if I distribute it back in? I get ax plus cx. So look, I can undistribute something. So if I have 7x plus 10x, undistribute that x there, and I end up with 7 plus 10, which is why we call it 17x, because 7 plus 10 is 17. So that's what we need to do here when you have these two variables. We need to undistribute that x. Undistribute that x, and you're left with a plus c. Check that it's equivalent. X times a, ax, x times c, cx. Well, there's x. How do I get it alone? Well, x times something, let's divide by that a plus c. So x equals d minus b over a plus c. That is my solution. So when you run into these equations, when there's more than one x, so you need to use this technique when there's more than one x, when there's extra variables in these equations. So we end by looking at this equation here. B times x minus 3 equals ax plus 7b. Solve the equation for x. So solve the equation for x. That means my answer is x equals. So looking at this equation here, I'm going to distribute bx minus 3b equals ax plus 7b. So I need to get x alone. So let me get my x's on one side. Let me get my x's on one side of the equation. I'm going to subtract ax here. I have no idea what bx minus ax is, so I'm just going to leave that. Minus 3b equals 7b. So I need to get x alone. Well, this term here doesn't have an x, so let me add it over. bx minus ax, well, that's 10b. So again, I need to use that undistributing technique. Let me go over to the side here. If I have bx minus ax, what do they have in common? What's that common factor there? X. So undistribute that, and you get b minus a. So this here is really b minus a, and I undistributed an x. Equals 10b. So how do I solve for x? I divide. And I get x equals 10b over b minus a. Notice I solved for x in terms of a and b. Were a and b in my answer? Yes, but I got x equals. I solved for x. Notice here now, I want you to solve for a. Solve the equation for a. That means a is what I'm getting alone. A equals is what I'm looking for here. So I have bx minus 3b equals ax plus 7b. So I'm solving for what? I'm solving for a. I'm solving for that a right there. Let's subtract 7b from both sides, because I want to get a alone, because I can solve for a. Well, how do I get a alone there? Well, a is what I'm solving for, so a times x. I want to get rid of that x. I'm going to divide by x there. Do not slash those x's out. Leave it as it is. So I get a equals bx minus 10b all over x. That is my answer. I solved for a. I got a equals in terms of b and x. So that's my solution. And finally, solve for b in terms of a and x. Let me just copy it over one more time. I'm solving for b. So bx minus 3b equals ax plus 7b. So I'm solving for b. Solve the equation for b. So let me get my b's on one side. Let me subtract b again. I want to get my b's all on one side of the equation. So notice everyone has a B is on the left-hand side, no one has a B on the right-hand side. It's like a middle school dance where all the boys go on one side and all the girls are on the other side. I want all the boys on one side together. And then I don't know what that is there, so let's undistribute the B. Undistribute the B and you get x minus 10 equals ax. I undistributed that B. B times x is bx, B times negative 10 is negative 10b. Well, how do I get b by itself? It's being multiplied by this thing, so let's divide by that thing. So b equals ax over x minus 10. That's my solution to this equation here. So these last three were tricky, but the big idea here is if I ask you to solve for b, you need to know I want to get b all by itself. In terms of a and x are going to be in your answer. So hopefully these letters didn't scare you. I know it seems daunting, but just think about the few legal moves we have in mathematics. We can distribute, we can use the addition property of equality, and we can use the multiplication property of equality. That's basically your only options when you work with these equations with extra letters in them.